Hi everyone, welcome to the Elastic setup guide. And this video I want to show you the process on how to set up Elastic on your computer so you can actually try out everything, so you can actually play around with all these functions that we have, and so that you can actually participate in the hackathon. So right now I'm actually redoing this process, so I'm sorry, I have to just remove everything. So basically you start from scratch. You have two command line windows, you will need them. And what you have to do now is basically check out the source code. We have two different repositories. So one is for the Elastic reference client. It's basically the front end and the thing that you interact with. And on the second hand, we have the Elastic miner, which you will actually also need to test the mining functionality, which is basically essential in Elastic because it's different from other coins, right? We are mining user-provided algorithms, so this is essential and also needs to be tested very well. So in the first step, you have to check out both repositories. Let's do it with the first one. What the hell? No Adobe plugin. So you get the clone URL from here, switch to your console, and then you just invoke git clone with the reference client repository. Yeah, it takes some time because it's pretty big right now. Yeah, come on. There you go, so you have the reference client. Now in the next step you need to do the same thing with the Elastic miner repository. There you go. Copy the URL and clone it. Now you have everything you need to try out Elastic. So first of all, we go to the Elastic reference client, and what you see now is basically the base directory, and you have two bash scripts, one for compiling and one for running. So let's first of all compile the whole thing. There you go. And the next step, you can run it. There you go. Now Elastic is up and running. You can verify yourself if you go to your browser into 127.0.0.1 colon 7876, and you will be presented with the Elastic welcome screen basically. So in the test version we just have one account, it's the test account, and it's basically using the passphrase test. So let's log in, test. You get a warning because it's a very short passphrase. You should never ever use a short passphrase in a productive environment because it will be easily hacked. So it's basically a brain wallet, right? But for now, let's use test. Enter once again, and there you see the Elastic welcome screen. So you have all 5 million coins right now in the test account, which is fine. And in the next step, we will create a work package. So we go in here, basically cloud computing, get your work done. And then you see this list, which is empty right now for obvious reasons. We have just started a fresh blockchain. It's all local, it's all run locally, so no wonder. Basically, we have to click this link, and then we just give this work a title like tests. We attach 100 XEL. This sucker does not work at all, this one actually, but it will be fixed very quickly. So 100 XEL basically means that this amount is split up in 60% for the proof of work fund and 40% for the bounty fund. So basically this means that 60 XEL will be given away to miners who solve proof of work functions, and 40 XEL will be given to people who solve bounties. The difference is basically that we need some kind of feedback, because it's possible that someone is just looking for one solution. So you have a problem and you just look for one solution, But still, we have many miners who need payments continuously. So we need this continuous feedback where people prove that they're actually working on the program. And this is basically the proof of work fund, which is spent to those who prove that they're working on it. And the bounty fund will be split after the work has been closed among all people who have submitted a solution, which actually means something to the user. So right now and when you go back to the console, you have some example scripts, because Elastic uses an own programming language, the Elastic PL, Elastic Programming Language, and proof of work functions are actually coded in this own programming language. We need this programming language because we cannot execute arbitrary code on the user's computers because it's just not safe. So we have an own programming language which is very restricted and does not allow everything. It does not allow to read from the disk. It does not allow to exploit buffer overflows or anything. So it's pretty safe. Let's take a look at the folder Elastic PL examples. There's a example script which is actually something like this. And this is a very simple program which will mine the Bitcoin Genesis block, because yes, you can use Elastic to mine other coins. And this is basically, so every Elastic program starts with an input line. So this is actually how many random integers the miners provide, basically. So the minimum is 3, so we have no collisions, because it's actually 48 bits. 42 bits actually, 42 bits. And no, I'm lying. It's actually 3 times 32 bits. Okay, I'm sorry. These are actually stored in the M array from 0 to 2. And the other M arrays, you have 256 at most to prevent buffer exhaustion, basically, some denial of service attacks by flooding the user's buffers. So we have just a limited amount of space that you can actually use in the user memory. And we have actually put in the Bitcoin block from block 0 in here. The M22 is actually the nonce that we are looking for. I've made it a bit easier so we can see bounties pretty quick. And then we invoke twice SHA-256, basically once for 80 byte, which is the whole block header, and then a second time we hash the hash, which has 32 byte, right? And the last line, every Elastic programming language program has to have a verify line, which describes what a valid bounty is. So we only want solutions to our program where M10 is 0. So M10 will be basically the hash. This will be described in the specification, but actually the hash of the hash will be stored in these integers, and we just check for leading zeros. So this is the Elastic PL program that we want to use. Let's find it. There you go. Elastic reference client, Elastic PL examples, actually, good EPL. There you go. Then you have to put in your passphrase, submit the work, and there it is, unconfirmed work. Now we are not forging, so Elastic uses proof of work for the user-provided algorithms, but the blockchain integrity is actually achieved using proof of stake. Let's start forging, so we find new blocks and we get confirmations, right? There you go. Test, start forging. There you go, it switched to active Elastic PL programming language, valid for 250 blocks. And here you see 60 XEL is actually in the bounty, in the proof of work fund, and 40 XEL is in the bounty fund. Right now everything is refundable. You have to understand it like this. The proof of work fund is deducted on every proof of work submission. And once you cancel the work, which you can do here, you get refunded the proof of work fund. The bounty fund is refundable as long as no bounty has been submitted. Because once we have one bounty, it gets the entire bounty fund. Or if you get two bounties, the bounty fund is split among two. But you cannot refund the bounty fund if you have submitted a solution, right? So the work is active, and we can use the miner to work, start working on this problem. I'm sorry, my English sucks sometimes. So let's go into the Elastic miner, which is a jar file. I compiled it for you so you can actually easily set it up. Let's go ahead. Java minus jar. You need Java 1.8 because older versions will not work. There you go. This one, and Lannister needs to set up some bounty. We need a beautiful miner. This one is a proof of work miner. It's a proof of concept basically, and it looks shitty, right? But it works. So you need to enter your account password, verify that your ID and your Reed Solomon code matches, which is above here. It works. Confirm with an enter, and then you will see when you go back. Actually, it takes 5 seconds. There you go. Let the games begin. Found hash. So you see proof of work, bounty submission, proof of work. Everything works. The miner is doing its work. It's submitting proof of work packages. It's submitting bounty submissions. And right now it's configured just for testing. It will be made dynamic that every proof of work package gets 10 XEL, right? This will be dynamic, but right now it's just for testing. So as you remember, the proof of work fund contains 60 XEL, which means that we will find at most 6 proof of work packages, because then the money is gone, right? Let's see what happens. Okay, we found only 5. Next block will be found in 3 seconds. Let's see what happens. Confirmations, none. Now we have a few. And the work was cancelled. Okay, I must counted it wrong. We got 6 proof of work. Why the work was cancelled? It's because the proof of work fund was drained to 0, because we had 60 XEL in the proof of work fund. We got 6 proof of work packages, and this means that basically something went on. Let me check. Okay, let's count. Proof of work, that's 2 on this page. 3, 4, 5, 6 proof of works, right? That means that 60 XEL were paid out as a proof of work, and as we are the only one who created bounty submissions, we got the entire bounty fund of 40. So when you check out, you see that the balance is 5 million XEL again, and if you check out the work, it's cancelled. I will make it a little bit more clear, because cancelled is not cancelled. Cancelled can mean that it was cancelled because it ran out of money. So you see 0 XEL refunded because, okay, proof of work was gone. Bounty submissions were there. They were also gone. So nothing was refunded, job was finished, and actually it should say finished, but it says cancelled anyway. This is basically it. It worked fine. I need to fix up some parts of the UI. It's a very small thing, but you see, because bounties have been already submitted, you cannot refund the bounty fund. So proof of work was drained, bounty fund was drained, and so on. So the work cancellation actually paid the bounty. Anyway, so what you have seen is basically I created a work package using ElasticPL. The miner started working on it, generated bounty submissions, generated proof of works, as long as money was in the proof of work fund. Once the job ran out of money, it was closed and it's done. We have 5 million XEL right now. So there you go. This is basically how you set it up.